Okay, so we're going to try and solve this problem right here. And the process to solve it will actually be very, very similar to the process to solve the other types of ones we've done before. The only issue is that this number here is not one of the known values. It's not 1/2 root 3 over 2, root 2 over 2. So we're going to need to use some calculator and some logical thinking to get there. So I think you don't have any issues with the sine inverse stuff. You know, we take sine inverse of both sides, and we end up with 3 theta equals sine inverse negative 0.81. And then whatever that is, we divide it by 3. So let's go ahead and do that. So sine inverse negative 0.81 divided by 3. Now, if we actually plug this into a calculator, see, I've already done a bunch of these, but sine inverse right here, negative 0.81 divided by 3. Now, we actually got this number last time, and we said, oh no, it's not in the answers. We must have done something wrong. The first thing to realize is that that's not quite right. I mean, it is not in the answers, that's true, and it's actually also outside of our range, which is pretty important to consider. It's not between 0 and 2 pi, it's a negative number. But this is a solution. It's just a negative angle, right? So you can get, if you go around a unit circle this way, you get positive angles. But if you go this way, you get negative angles. And this is just a negative angle. How can we turn this into the same positive angle? Well, we could just add 2 pi to it. So we're going to add 2 pi to it, just to convert it from the negative version into the positive version. And we'll actually get, once we do that, just going to add 2 pi to this plus 2 pi. We get 5.968, which is our first solution. And that is actually in the answers. And again, these two numbers, these two positions are exactly the same, except that this one's the positive version. So that's our first solution. So the other thing to consider is that from here, what we usually would do is we would find the other place where sine equals that thing. So for example, if we were dealing with something like sine of theta equals root 3 over 2, right? Once we do our sine inverse, we don't really even do this in our heads, or we don't really do this on the paper, but we do this in our heads. But once we do the sine inverse, we just know that theta is going to be equal to the one place where sine equals root 3 over 2, which is going to be right here. And we also know the other place where it's going to equal root 3 over 2 right here. So we would have those two angles, pi over 3 and 2 pi over 3. And how do we do that? Well, we just kind of know. We always just kind of know. We've memorized the unit circle, so that's easy. So how do you do that when you don't know the position of this angle, when this is like a pretty weird place? It's not one of our known values. So it turns out, really what you're doing when you do this in your head, you just think you're thinking to yourself, well, I have my one position in the first quadrant, that much I know. And then really you're just looking for the same place flipped across the y-axis. So flip this across the y-axis, we get the other location. And that's true for any sine solution we're looking for. For example, if we're looking for, we know that it should be 7 pi over 6. If we flip this across the y-axis, this will be the other place where sine equals the same thing, negative 1/2, negative 1/2. So all we need to do to find where sine equals the other solution always is just flip it across the y-axis. Easiest way to do that is just to take whatever angle we have and subtract it from pi. So what I'm saying here is that you can always do pi minus theta to get the other solution. Now this is only for sine. For cosine, it'll be a little different. I'll show you that after this. But for sine, you can always do pi minus theta to find the other solution. So if we actually do this pi minus thing, we'll find that we get pi minus 5.968. Let's plug that in, pi minus 5.968. And hopefully it should make sense. This will be a negative number because pi is like 3.14. 5 is obviously greater than that. But we can just convert that again, just like we did before, by adding 2 pi. And turning it from negative angle into the positive angle. And this actually is going to be your other positive place where that's going to be one of our solutions, 7, 7. So, okay. So we have now our two solutions. So theta equals, we have our two first solutions. Just like we would do if we were doing sine of root 3 over 2, you know, we can even say it's we have 2 theta here. We would have found our two solutions as being root 3 over 2, and, or sorry, would be our solutions as pi over 3 and 2 pi over 3. And then we would just keep adding our period until we got outside of the range. So in this case, our period would be 2 pi over b, b would be 2, so our period would be pi, so we would add pi to pi over 3 plus pi and 2 pi over 3 plus pi. We would add it until we got outside of our range, which in this case is 0 to 2 pi. So we actually do the exact same thing here. These are sort of our base solutions where we're going to start from. And then we just add or subtract our period to get all the rest of them. So we know there's a 3 here on our problem. So we know there's going to be 3 times the solutions that there normally would be. Usually there's 2 solutions, so we would expect 6 solutions. So how do we get the 6 solutions? We just add and subtract our period. So I'm going to take, here, I'll move these over here. And then we'll take this one as well. And let's do that. So our period is going to be 2 pi over b. Our b is 3, so it's 2 pi over 3 is what we're going to be wanting to add or subtract. Now, one thing to recognize here is we're working with decimals, but our range, or sorry, our domain is set in this 2 pi format. But 2 pi is just 2 times pi, 3.14, so it'll be about 6. So we can't get outside of our range. So one thing we wouldn't really want to do here is add 2 pi over 3 to this one, because that would immediately get us outside of our range. If we do 5.968 plus 2 pi over 3, we would get greater than 6. So this solution, this 8.06, is outside of our range, so we wouldn't want to do that. So we probably actually want to subtract by 2 pi over 3 for our first thing. And that will be our first other solution, 3.873. And our bottom range is 0, so we can actually add more, or we can subtract more 2 pi over 3s. So I'm just going to multiply that by 2 to subtract another one, and this will be another solution for us, 1.779. And if you multiply this by 3 to subtract another one, you'll see we actually start getting negative, so we're below 0 now. So these are 2 solutions right here. We do the same exact thing for this other solution we found. Here we can actually see that we can actually add 2 pi over 3. That'll be slightly less than 6, 3.45677 plus 2 pi over 3. So that'll be 5.552. That'll be one of our solutions. And then if we tried to add another one, obviously it would be too large, over 6, so we can't do that. But we can also just subtract the 2 pi over 3 from this one. We get 1.363. And just to show, if we try to subtract another 2 pi over 3, we would get negative. So that's outside of our range. These are the other 2 solutions. So here we have all 6 of our solutions. Or this one, this one, this one, this one, this one, and this one. Hopefully that makes sense. So as I was saying, the only hard part here is just knowing how to find the other solution, the part that we usually do in our head, knowing that, you know, sine equals root 3 over 2 at pi over 3 and 2 pi over 3. How you do that when you have some random angle like this one. This was basically our angle here. How you find the other solution? Well, you just reflect it across the y-axis always. And how you do that, you just subtract pi, and that'll always get you the other angle that you're looking for. That would be in this case. For cosine, it's slightly different. So for cosine, instead of reflecting across the y-axis, you actually want to reflect across the x-axis. So for example, if you're looking for where cosine equals root 3 over 2? Well, we know it's at pi over 6, and the positive root 3 over 2 would also be at 11 pi over 6. And really what we did there is a reflection across the x-axis. So all you need to do for that actually is just take your angle and make it negative. So whatever angle cosine is at, you just make it negative, or if it is negative already, you make it positive, and you'll find the other angle. So for example, cosine is negative root 3 over 2 at 7 pi over 6. So where else would it be negative root 3 over 2? Well, we just take 7 pi over 6, make it negative, which actually is, not a positive angle. It's negative 7 pi over 6. But we can always just add 2 pi. And if we do that, we'll actually see that it'll be equal to 5 pi over 6 because we reflected it across the x-axis, which is exactly what we want to do. And then once you have those two base solutions, then you just add and subtract your period, just like we've done before, to find the rest of your solutions, as should make sense. So for sine, you take pi minus the angle to reflect across the y-axis. For cosine, you just make the angle negative, or you could also subtract by 2 pi. That would accomplish the same thing. But I think just taking the negative would be a little simpler. And always feel free to convert your negative angles into the positive ones just by subtracting 2 pi, or adding 2 pi rather. Hopefully that makes sense. So for this one, that should be pretty solvable. You just subtract 2 for both sides, and then you follow the exact same process. You would find the two solutions for cosine. One of them you get from your calculator. One of them you just make the negative angle reflected across the x-axis. And then you just add and subtract your period until you get all the solutions that are still within the range of 0 to 2 pi. Greater than 0, less than 6. All right, hopefully that helped.